Hello, good morning. This is Mr. Jackson, and today I'd like to talk about the basics of systems. What is a system? It's when we take multiple objects and we attach them together, which results in multiple forces and the objects together moving as one object as a team. Okay, so I just wanted to practice right now just some simple ideas and trying to draw these forces, identify everything going on. So let's just draw some systems. Let's say we have a truck, okay, and this truck has an attached trailer to it, okay, and we want to find out what are all the forces on both objects. So we know we have a force of weight, we have a force normal. Right now, let's just assume that they're driving down the road. We'll go with constant velocity or speed. We know that this object has a force applied then to actually be able to move, okay? And then there would be a force of tension from the trailer, okay? But also then the trailer would have a force of weight. Since it's on the ground, it would also have a force normal. It would have a force of drag if I wanted to say there was air resistance on it. So it's going in this direction. Let's say we have a force of drag. Okay, and I'm going to ignore friction from this problem. Let's say we have wind on the car. So we got air particles. So we have a force of drag. And then we have, of course, the cable or the hitch is pulling forward. So we have force of tension also pulling forward, which would be the same force as acting backwards. So if I threw in drag and I considered it, then I would see just on the car alone, I would see 1, 2, 3, 4, 5 forces. But on the trailer, I would only see 1, 2, 3, 4. Okay? So that's kind of depending on the wording. Now, if I said there was friction, I would have to add another force in there. So based on the reading, but from what I gave you. So let's look at another idea and what we would draw. Let's say we have a helicopter that's lifting something up. So here's my cheesy helicopter. And it is lifting a box. Let's make it a little bit farther down here. So what are all the forces on this system? And let's just say it's hovering, which means it's just sitting there in the air. It's not accelerating up or down, but it's just sitting in the air. Here's the ground. Okay? Then I know I would have force of weight acting downward. Have to. Also, the helicopter would have a force of weight. Okay? But if to hover, it would need a force of thrust upwards. And then the cable in the box, if it's off the ground, this would have a force of tension. But then the cable in the box would also have the same force of tension acting upward. So that's an upward force, and this is a downward force. And then it would have the force of weight. So this one would have 1, 2, 3 forces total. And then this box would have basically 1, 2 forces. Okay? Let's look at another system. Maybe we want to have a car, or anybody ever see those big gigantic trucks on the road? They have multiple mail they're sending down. So let's say we have a truck here. Try to draw a bigger truck this time. And then it ends up having a whole bunch of vehicles in the back, because remember they carry, these mail trucks sometimes carry 2 or 3 or a tandem. My brother, he actually drove to Canada. He would like to have a trailer and a boat, so he would be pulling 3 things. So I know this is kind of a cheesy little thing, but how many forces are on each of these objects? Well, let's say we do have friction this time. We know we have force of friction on the road. And let's say we actually don't have any air drag. Let's just say we have friction on the road. And we have friction on the road. Okay? We know each one of these has a weight. And since they're all on the ground, they each have a normal force. But then they each have also a force of tensions both ways. This one has a force of tension and a force of tension back again the other way. So if I looked at the first car, I know that the truck, if it's moving, let's just say constant speed, then it would have a force applied. So I would have 1, 2, 3, 4, and the tension would be 5. So this one would have 5 forces. This one would have force of tension, 1, 2, 3, force of drag, 4, 5. This one would have 5. But the end one would have the tension and a normal, a weight, and a friction. So it would only have 4. Okay? So those are all the forces. Now remember, if they're going to move together, if these all had a mass, if I did know the F net, and I wanted to find the acceleration, let's just say I had all these numbers and I could find this number, what would I do? How would I find acceleration? It would be F net divided by m, but I would have to add all 3 of those masses. Let's call this mass 1, mass 2, mass 3. Because remember, we told you that they're all going to be moving as one object. So I would have to add all these together and have a total mass in my math. Just want to point that out. That's something that's very important to know, because that's going to be happening here. We would have to add all 3 of those numbers. Okay? Let's try another diagram or drawing. Let's see what we've got here. Okay? Let's look at maybe a situation where we have some objects attached to the ceiling and on a pulley. So here we have a couple pulleys. We have this box over here, and we have this box over here. Let's make this one bigger. Okay? And what's going to happen? What are the forces on here? Well, you know, when we have something like this attached, we know they're going to begin to move. Okay? So we have this one with a large mass and then a smaller mass. Okay? What do we have? We have, well, force of weight acting down here, force of weight acting down there. Okay? And let's just say it's moving so slow, so it doesn't have any drag and it doesn't have any friction. This is a weightless cable. Is there any normal forces? No, they're not touching anything. They're not sitting on a surface, so there's no normal forces. Okay, and this is pulling up, so we have force of tension up because it's pulling on this box, but then this box is pulling back, so there's another force of tension. Okay, upward. So we would have tension. This would be up. This would be up. Okay. Is there any other forces I could think about? Sure, there's force of weight down, but then which way would they accelerate? That's a good question. The acceleration for this one, since it's more massive, would win, so acceleration would be downward. Here, the acceleration would be upward. Okay? So we need to be careful on that because that's the way it would work. So these are the forces. I would say this one has 2 forces to deal with, and this one also has 2 forces. Okay? Let's make it a little bit more complicated and see if we can identify all the forces in another situation. Let's say that we're dealing with a box sitting on a table, and this box is encountering some friction, but it's attached to another box which is hanging down and suspended by a table. So what forces do I have here? Well, I have force of weight. It's not touching the ground, so there's no normal force. They're not moving really fast, so we're not going to say there's any kind of air drag, but it is moving. Okay? And in its movement, we know it's rubbing over here, so we have other forces going on. So this box actually has a force of weight like this one, but this one has a normal force, whereas this one does not because it's not touching a ground, so, or being supported. This one has a force of tension, but this one is being pulled on also, so it has a force of tension, and it's touching the ground, so it's got a force of friction. So this one only has 2 forces, but this one has 4 forces. Okay? And so we need to be careful on how we evaluate. This one would actually move downward. My acceleration would be downward. This one's acceleration would be horizontal. And they would move together, so whatever this acceleration is, it's also the same answer over here. So I just wanted to kind of draw you some ideas of how forces work when things are attached together in a bigger system. Okay? It's very important that you be able to identify that kind of idea. So think about that. Remember, when it's on a surface, you do have a support force. When it's not, you have no normal forces. Okay? And so you also may have frictions over here, but there's nothing to rub against here, so there's no friction over there. So just depending on how the system is set up, you may end up having different kinds of forces available on different objects. Okay? There you go. That's the basics of how to draw simple systems and where they're attached and how their forces work back and forth. Okay?